In this example, we will use the traditional method to test a claim that there is a difference between self-reported heights and measured heights of males aged 12 to 16. Let's start with HO and H1. If there is a difference between self-reported heights and measured heights, then the mean of the differences cannot be 0. So that would be our claim. So the null hypothesis would be that the mean of the differences is equal to 0. Our numbers are larger than the previous examples, and the sample sizes are larger too. It would be best to pause here and watch the viewlet to learn how to use your calculator to find the differences, and then the mean of the differences and the standard deviation of the differences. So using your calculator, you should have found that the mean of the differences is equal to negative 1.00. The standard deviation of the differences is equal to 3.52. And the sample size is 12. And now we can use that information to find the test statistic. T is equal to negative 1.00 divided by 3.52 divided by the square root of 12. Work that out, round to 3 decimal places, and you should end up with negative 0.984. You can also use t-test on your calculator, and you would also find that way that t is equal to negative 0.984. Now let's find any critical values. Because of the not equal to sign in H1, we know that we have a two-tailed test. They told us that alpha is 0.05, so we have 0.025 in each tail, 0.95 in the center. Since the sample size is 12, the degrees of freedom would be 11. So using table A3, you should find the critical values to be negative 2.201 and a positive 2.201. The test statistic of negative 0.984 is between the critical values and not in either critical region. Therefore, we fail to reject the null hypothesis. The claim is with the alternative hypothesis, and we fail to reject the null hypothesis, so there is not sufficient evidence to support the claim that the mean difference is not equal to 0.